Here's a matrix, and I want to find the inverse of this matrix. I'm going to do it by row operations and Gauss-Jordan elimination, and I'll show how to do that in a second. Why do I want to take the inverse of matrices? If I have a system of equations, let's say 3a minus 2b equals 7, and then I have 2a plus c equals 1, and I have 4a plus 2b minus c equals 3. I can set up a matrix. This is 3a, negative 2b, 0c, so I'm going to put 3, negative 2, 0. This is 2a, 0b, and 1c, and this is 4a, 2b, and negative 1c. And then I multiply it by another matrix, which is the ABC, just 1 by 3. I'm sorry, 3 by 1, 3 rows, 1 column. And then it equals, and here are the solutions, 7, 1, 3. I can find the answer to this system if I take, this is matrix A times matrix B equals matrix C. If I take the inverse of matrix A and multiply it by both sides, this becomes the identity matrix, which now gives me B equals the inverse of A times C. So if I multiply the inverse of this matrix times this matrix, I will get answers. I will get the solutions for the system of equation. I will get a value for A, a value for B, and a value for C, which solves it. Let me go to the Desmos. How do I do this? I need a new page maybe. Desmos, and I will put this one in just to show how it works. Because normally these aren't done by hand. It's done by calculators. But you have to know how to set it up, and it's good to know how to find the inverse by hand so that you realize how much time you're saving by using a calculator. 2, 0, 1, and this is 4, 2, negative 1, and then a new matrix. And for the new matrix, I have 3 rows and 1 column, and all I'm going to use is this answer one, 7, 1, 3. 7, whoops, 1, 3. Now I'm going to want to do operations. So I'm going to do A, but I'm going to do the inverse of A times B, and the answer I get is that, and those are the answers. So it's 11, A is 11 ninths, B is negative 5 thirds, and C is negative 13 ninths. And that would be the answer. So that's why I try to find inverses, and I can find the inverse of this equation. To do it by hand, you saw how easy it was to use a calculator like Desmos. You can use a TI-84 and find the inverse of the matrix, very easy. But to do it by hand, I take the identity matrix and I put it on the right. 1, 0, 0, 0, 1, 0, 0, 0, 1. And now I will do row operations. I will add and subtract some multiple of one row from another row, or add them together until I can get this one on the left to look like this one. And once this one is 1, 0, 0, 0, 1, 0, 0, 0, 1, then the one on the right will be the inverse. So let me get a little bit more room for this because I've infringed on my space. I've uninfringed. And let's see, I want to try to get these first positions. I look at the upper left-hand corner. I try to get these two to be zeros. I want to get rid of those marks because it made them look like negatives. But I want to get row 2, column 1, row 3, column 1 to be zeros. I've already got a 0 in row 2, column 1. How can I turn that 5 into a 0? Well, if I take row 3 and I form a new row 3 by taking the original row 3 and minus 5 times row 1. 5 minus 5 times 1 is 0. So I'll get a 0 in that leading position. And always write down what your row operations are. So you can maybe find, if you make a mistake, you can go back and find it. So the first row I'm not doing anything to. Second row I'm not doing anything to yet. Third row is row 3 minus 5, row 1. 5 minus 5 times 1, 5 minus 5 is 0. 6 minus 5 times 2, 6 minus 10 is negative 4. 0 minus 5 times 3, 0 minus 15 is negative 15. Then 0 minus 5 times 1 is negative 5. 0 minus 5 times 0 is 0. 1 minus 5 times 0 is 1. So now I've got a new matrix system here, and I still want to get this. I want this to be 0, 0. I want that to be 1. So if I take row 3, and I make a new row 3 by taking the original row 3 and adding 4 times row 2. Because negative 4 plus 4 times 1 is 0. So that's I want this to be 0, 0, 1, row 3. So row 1 is still going to be the same. Row 2 is going to be the same. I haven't done anything with those yet. And row 3, I'm doing row 3 plus 4, row 2. So 0 plus 4 times 0 is 0. Negative 4 plus 4 times 1 is negative 4 plus 4 is 0. Negative 15 plus 4 times 4, which is 16. Negative 15 plus 16 is 1. Oh, look, row 3 is set, 0, 0, 1. Excellent. Negative 5 plus 4 times 0 is negative 5. 0 plus 4 times 1 is 4. And 1 plus 4 times 0 is 1. Okay, now I've got this beautiful row 3 that I can use to get rid of the third numbers in row 1 and row 2. So maybe I'll do both of these at once. Row 1, I'm going to get the new row 1 by doing row 1 minus 3 row 3. Because 3 minus 3 times 1 is 0. And then I'll do row 2, and I will do, I want to do 4 minus 4 times row 3. So I'll do row 2 minus 4 row 3. 4 minus 4 times 1 will be 0. Okay? I'm trying to get this so I can get it all on one screen. So I want row 1 minus 3 row 3. 1 minus 3 times 0 is 1. 2 minus 3 times 0 is 2. 3 minus 3 times 1 is 3 minus 3, which is 0. Hooray. Now, 1 minus 3 times minus 5. Negative 3 times negative 5 is 15. 15 plus 1 is 16. 0 minus 3 times 4 is minus 12. 0 minus 3 times 1 is minus 3. Okay? Now I'm going to do, I just had a sinking feeling that I'm not recording. No, I am. Now I'm going to do row 2. Oh, I put this in the wrong spot. I did row 1 minus 3. 1 minus 3 times negative 5 is 15, plus 1 is 16. This is supposed to go down here, because that's row 1. I'm just double checking it. 0 minus 3 times 4 is minus 12. 0 minus 3 times 1 is minus 3. Okay, row 2 is row 2 minus 4, row 3. 0 minus 4 times 0 is 0. 1 minus 4 times 0 is 0. 4 minus 4 times 1 is 0. 4 minus 4 is 0. 0 minus 4 times minus 5 is 20. 1 minus 4 times 4, 1 minus 16 is minus 15. And 0 minus 4 times 1 is minus 4. And then row 3 hasn't changed. 0. Wait a minute. This should be 1. Why didn't you tell me this? 1 minus 4 times 0 is 1, not 0. I don't know where I got that. So I guess row 2 is done. And I've got 0, 0, 1, negative 5, 4, 1. Now I just have to finish row 1, and I'm going to do row 1, and I'm going to get that by doing row 1 minus 2, row 2. Because 2 minus 2 times 1 is 0. Then I'll be done with row 1. So this is 1 minus 2 times 0 is 1. 2 minus 2 times 1 is 2 minus 2 is 0. 0 minus 2 times 0 is 0. 16 minus 2 times 20. Oh my goodness. 2 times 20 is 40. 16 minus 40 is negative 24. Negative 12 minus 2 times negative 15. Negative 12 plus 30 is 18. And negative 3 minus 2 times negative 4, which is plus 8. Plus 8 minus 3 is 5. And then these are just what they are. 0, 1, 0, 20, negative 15, negative 4, 0, 0, 1, negative 5, 4, 1. And now, just to double check it, I'm going to take that original that was a different one. I want to take that original matrix, I'm going to enter it into the matrix calculator here, and then I will find the inverse of it. Just to double check my work. On the test you can't, while doing homework you can. 4, and then this is 5, 6, 0, and then I want to do A, and I want to do inverse A, and it's negative 24, 18, 5, 20, negative 15, negative 4, negative 5, 4, 1. So I indeed did find it right. So remember, the key was, first I want to try to, in general, try to get a 0 and a 0 underneath the 1 in the first column, and then try to get a 0 and 0 above the 1 in the second column, and then try to get a 1 in the last position of the third column. But you can do it in all kinds of different orders as long as each step is valid and you keep moving towards turning this into this. And there's the answer.